Though I have solved this problem previously, but I want to solve it again. The problem, you can see that we have a flat spiral with a large number of turns in. It's a large number of turns. How many, I don't know. And the outer radius r, that is also important, is in a uniform magnetic field, the inductance vector of which is perpendicular to the plane of the spiral, and in the induction modulus, that means magnitude of that magnetic field changes according to the law of B equals B naught cos omega t. I deliberately use cos omega t because minus d phi by dt gets compensated. Find the EMF of the induction, that means induced EMF in the spiral. How can I solve it? Well, you don't know, you perhaps don't know, but the equation of a flat spiral is given like something like in polar coordinates it is given something like r equals a phi. What is this r and what is phi? If you consider an arbitrary spiral inside the spiral, if you take your two-dimensional coordinate axis and play like this and name it a point P and provided a coordinate r and phi, r and phi, this is your point P, this angle is phi and this length is r. And what is this A? A is called tightness of the spiral. This A thing here is called tightness of the spiral. Yeah. And it is usually written as A equals R by 2 pi n number of turns. Here value of phi varies from 0 to 2 pi r n. 2 pi r is the radius of an arbitrary spiral, thin spiral, and there are many like this, and everybody subtends a total angle of 2 pi r at the center of the spiral. So the value of phi varies from 0 to 2 pi n. That is the total angular spiral subtends for the outer radius capital R. That is why its tightness is defined like this. If you wish, you can find it on web or you can find in a textbook. Any textbook has been written. It was an interesting problem given in some Olympiad. So I'm trying to solve it. I know I can solve it. How? If I consider the whole thing, though I don't want to remove this picture, but I have to do it because I don't have any option. So if I remove this thing and we have some results, you can memorize it and come back again and see this. Then in order to solve the problem, the magnetic field, this is part of a spiral and the magnetic field between these 2 points, sorry, the EMF induced in this spiral was asked, and the magnetic field was something like this, where B was given as, magnitude of B was given at B naught cos omega t. So there is a time varying magnetic field. So flux is going to be introduced in each turn of this spiral. If I consider this a special spiral of radius r, you can write the Faraday's law for this, like E dot dl. This is the EMF induced. To just the induced EMF I wrote in terms of E and dl, and you can write it as minus d phi by dt. And again you can write minus d phi by dt as minus dB by dt into its area, that is pi r square, and this whole integration will come out somehow E into 2 pi r, and cancel out pi from both sides and r from both sides. You will get electric field equals minus 1 by 2 d by dt multiplied by r. 1 r is left here. So you will get this result. You are bound to get this result. But what then? You can do nothing. After that, I suggest you to write the equation of the spiral, and remember that A is r divided by 2 pi n. From higher mathematics, of course. The spiral is not the part of +2 syllabus, but this can be solved using the concepts of +2 syllabus, and I've solved it already. But people were furious about the solution. This is non-understandable, so I'm trying to solve it methodically. And you know that this induced EMF I have already written as E dot dl, that will become simply E dl, because electric field dl, you know the dl length. Dl length is taken over any circle. It is tangential, and E induced is also tangential. So E dot dl will be simply E dl in this case. And if I think of a dl like this, I can write it E r d phi. Because dl can be written here in terms of r and phi as r d phi. I'm using the polar coordinates because I have the equation of a spiral in the polar coordinate system. So E r d phi you can write here. E you can write here simply, I already got minus half dB by dt r, and then multiplied by r d phi. So you will get r square here, and this induced EMF was the goal of this problem to find. Ultimate goal was to find the value of induced EMF. So I am writing it minus half d by dt r square d phi, and in the next step you should write minus half dB by dt r equals a phi, so that it becomes a square phi square d phi. And now you are going to get your result simply by writing a equals r by 2 pi n. So I'm going to write one more step, and I can write it minus half dB by dt is equals a square. That means r square not r square, sorry, you can write r upon 2 pi n square phi square d phi, and this is still the value of d. And since b was given as b naught cos omega t, so dB by dt or minus dB by dt or simply dB by dt can be, we can find from here that dB by dt equals b naught omega sin omega t with a minus sign, and those minus will get cancelled out from here. So you can write the value of your dB by dt, and dB by dt is the function of t, and if we are going to integrate to find out dE, you will get those values, half dB by dt with a minus sign gone, b naught omega sin omega t thing, and then you will get here like r upon 2 pi n square, and then you will simply integrate phi square d phi, and phi values from 0 to 2 pi n, and you will get your result. That result is going to be interesting. I don't remember the result, and I am not in the mood to integrate this because anybody can integrate this. So you do the rest of the things, and thank you very much for watching.